Today we're going to talk about inverse functions, so please make sure that you have your page number, the name, and the date. You can always get the page number when you join our class virtually. In the title of the notes, inverse functions. We're going to start off with the definition of inverse function. So if you need to pause the video to get all of this down, please do so. The definition of an inverse function is a function that undoes the action of another function. So what that means, when you're writing that down, that means that you are going backwards. So if you have a function, the inverse of that function would be going backwards and getting what you started with in the first place. So I want you to see what that looks like in terms of function notation. So can you write for me inverse function notation? Inverse function notation. So today we're going to deal with what they look like as points and a graph. So inverse function notation. So we have a normal function f of x. That's what we're going to be focused on. So can you write if a function f of x, has an inverse, that is also a function, we represent it as and we would say the inverse of f of x, but it looks like this. You would have an f with an x, but you have this little tiny exponent of -1. If we had a graphing calculator, you'll notice sometimes it has that as well. These are called inverse functions. So this is the original function, f of x. When you see this means the inverse of f of x. So in order to find the values of this inverse, so if I give you a function and then say find the values of it, all we'd have to do, since we're reversing, we are switching the order. So can you write this little note for me? To find values of the inverse of f of x. So again, look at how I'm writing it. I have an f with a little tiny exponent of -1. That is called the inverse of f of x. So to find values of the inverse of f of x, switch the order of x and y. So I mentioned that an inverse function it's in the reverse order. You're bringing it back to the original. So if you have x and y on a original function f of x, you would have y and x on your inverse. So let me show you that in terms of points. So can you put example A for me? I'm going to shift this up a little bit. And can you write find the point? This is our first example. Find the point on the graph. I know it's a lot to write, but when you look back, you'll hopefully be able to see where this came from. So find the point on the graph of the inverse. And I'm going to put in parentheses y equals the inverse of f of x. Because when we're talking about graphs, we always start with y equals, and we're referring to the inverse function. So find the point on the graph of the inverse if each point is on y equals f of x. A lot to write, I know, but I'm going to get into some examples. So I'm going to give you a point right now. This is going to be example 1, and the point is going to be 9, -2. So can you put that in parentheses for me? If this point is on the function, the point on the inverse of it is just to switch these numbers. So the answer would be -2, 9. So all you would have to do is just switch the points, switch the numbers. Well, let me give you another one, example 2. -4, 3, can you put that in parentheses? If that point is on the original function, the point on the inverse is just flipping these numbers. So what would that be? That would be 3, -4. So same numbers, you just switch them. One more, example 3. If I have 0, 5 as a point, what would be a point on the inverse, the graph of the inverse? Well, you would just switch it and write 5, 0. So that's how you would find points on the inverse of a function. Now we're going to look at graphs. So I'm going to take this off and flip to the next page since I'm running out of room. I'll move my paper out. So now we're going to look at graphs. So can you write for example B? The function y equals f of x is below. So what I'm going to do now is I'm going to have you make a graph, and we're going to make a sketch of this little drawing. So we're going to make our x and y axis. So here's our x and y axis. And we're going to try to make this as best as possible. And again, it doesn't have to be perfect. So it's something like this, this, and this. And it's got 4 points on it. So if you could just make that little sketch for me. And I'm going to refer to this graph because it's a little bit easier to see. So this is our f of x function. We are going to make a table of these points, and we're going to look at this to help. And I know it's hard to see, so I will help you out with the numbers. So can you put for number 1, fill, oops, let me write that over, fill in table of y equals f of x. So there are 4 points, so I'm going to make a table. Usually we call it x and y. I'm going to call it x and f of x. You could call it x and y still, but it doesn't matter. I'm going to tell you these 3 points, and I know they're very hard to see. So if this is our graph, this first point is -5, -9. So can you put that in the table for us? This second point will be -1, -5. -1, -5. This third point is 2, 1. And this fourth point is 7, 6. The next thing I want us to do is fill in the table of the inverse points. So can you write for number 2, fill in table of y equals the inverse of f of x. I'll give you a second to write that down. So I don't even need this graph anymore. I can just look at this for reference. So remember on the previous page, if we have a point on a function, a point in the inverse would be flipping these numbers. So if I make a table, instead of x and f of x, we're going to put x in the inverse of f of x. That little -1 means inverse again. So if -5, -9 was a point on the graph, the inverse will have -9, -5. All I'm doing is flipping the numbers. If -1, -5 was on the graph, the inverse would have -5, -1. I'm flipping. If 2, 1 is on the graph, what point would be on the inverse? 1, 2. You flip. If 7, 6 was on the original, 6, 7 would be on the new. So there's our new table of points. The next thing I want to do is graph this. So can you take with your little graph, and we're going to graph these points. I'm going to put it on here first, and then you can make a sketch of it. So if I graph these, -9, -5 would be right here. -5, -1 would be here. So these would be my connecting. 1, 2 would be up here, and 6, 7 would be right here. So we are making a sketch of that. So I'm going to take my marker. We're doing it as best as we can. Remember, we're making just a sketch of it. So it should look something like this. I'll give you a second to draw that. And this probably should be a little bit down further. Way down here like that. The next thing I'm going to do is just talk a little bit about what you see. We're going to get rid of this right here. This does not belong. Okay, so what I want us to notice is that if I was to draw a line in between these two functions, so if I take my graph and if I draw a line, anytime we have a function and an inverse, they will reflect over this line. Can you take a dotted line and put a diagonal line through the center for me? There is a name for this line. This line is y equals x. So all of these points are 1, 1, 2, 2, 3, 3, 4, 4, and so on. So here's an important note. I'm going to give you 2 important notes and then we're done. The graph of the inverse, reflects over the line, y equals x. So if you're ever graphing the inverse of a function, you should notice that the function, whatever it is, will reflect over the y equals x line. Last thing I want to bring up, and then we're done. A function has an inverse. A function has an inverse. Only if f of x is 1 to 1. We have not learned that before, but I want to mention what that is. A function has inverse. There are sometimes functions that do not have inverses. Those functions, if they will have an inverse, must pass this thing called the horizontal line test. So can you put f of x must pass the horizontal line test. The horizontal line test. So what I mean by that is if we have a function, the inverse is a function if you can draw a line vertically and horizontally down the center. We'll talk more about that next time. Please make sure you put these notes in your notebook, take a picture, and upload them into Canvas.